Good morning, my dear students. In the last class, we discussed about the electric potential and electric potential difference. And from the definition of electric potential, we say that the work done in moving a unit positive charge from infinity to that point against the electrostatic force is called as electric potential. Today we will derive an expression for the electric potential due to the point charge. There is a derivation for the 5 marks usually asked in the examinations. So let's derive the equation for the electric potential due to the point charge. For that, we will consider a point charge. Say that here, I will consider a point charge at this point. Say that a point charge Q is placed at the origin O. Is placed at the origin O. Let P be a point. Let P be a point at a distance R from the origin. So here we have a point charge plus Q at the origin O, and let P be a point at a distance R from the origin O. So potential at P is the work done in moving a charge from infinity to this point. So say that here the potential can be calculated. Here we say that it is an infinity point. The work done to move a charge from infinity to this point. So at potential P is the work done to move a charge from infinity to this point. So to calculate the potential at P, we will consider the two intermediate points. Two intermediate points along the line joining OP. Right? So we will consider a unit positive charge. Unit positive charge, say that plus 1 Coulomb at point A. Right? So if I consider a unit positive charge at point A, the force between the plus 1 Coulomb and this charge is away from the charge. So force is in this direction because of the plus 1 Coulomb and this point charge. Alright? So now I will consider one more point B here, so that we can move this charge from point A to point B in this direction. Alright? To the small distance dx. To the small distance dx. Let this plus 1 Coulomb charge is placed at a distance x from the origin. Okay, so this is the diagram for the electric potential due to the point charge. We will consider a point charge at the origin O. Let P be a point at a distance R from the origin. We will consider 2 points A and B. At point A, we have placed a 1 Coulomb charge so that we can find the potential. So the force due to this point charge is in this direction. Right? So now say that I write here, consider a point charge, plus Q at the origin O, let P be a point, let P be a point at a distance R from O, at a distance R from the O. Let A and B are the 2 points on the line joining OP at a distance x and x plus dx, okay. So now the force experienced by unit positive charge, that is plus 1 Coulomb at A due to charge Q, okay. So this unit positive charge plus 1 Coulomb is experiencing the force due to this point charge, and these both are positive charges, that is why the force is repelled in this direction. So now there are 2 charges, one it is a point charge and there is one more charge, that is a unit positive charge. So if there are 2 point charges placed at a certain distance x, then we will use the Coulomb's law. So according to the Coulomb's law, we write that is F is equal to 1 divided by 4 pi epsilon naught Q1 Q2 divided by R square. That is what we have known. Instead of Q1 Q2, what we have? We have one point charge Q and one more charge, that is a unit positive charge, that is 1 Coulomb at a distance x now. Okay. Therefore, I write F is equal to 1 divided by 4 pi epsilon naught Q into 1 divided by x square. Right? So the force experienced by the unit positive charge, that is plus 1 Coulomb at A due to the point charge Q, is given by F is equal to 1 by 4 pi epsilon naught Q into 1 divided by x square. Now the small amount of work done, in moving a charge of plus 1 Coulomb from A to B is, we move a charge of 1 Coulomb from A to B. So now if I move a unit positive charge from A to B, I have done the work against this electrostatic force. Therefore, this dW is the small amount of work done, is given by F dot dx, or I will write that is F dx cos theta. We know this. That's the work done. So now work is done from point A to B, which is against the electrostatic force. We know that force is acting in this direction. The force due to the plus 1 Coulomb and due to this point charge is going away from the charges, which is repelled. and the force is this direction, and we are doing the work against this force, because we are doing the work from A to B, which is against the electrostatic force. So now here it makes an angle of 180 degree. So it is F dx cos 180 degree. So cos of 180 degree is how much? It is -1. Therefore we write dw is equal to minus of F into dx. Minus of F into dx. So we substitute the values of F here. So dw is equal to minus of, what is F here? So it is 1 divided by 4 pi epsilon naught q divided by x square into dx. This is the small amount of work is done in moving a charge of 1 coulomb from A to. Now the total work is done in moving a charge of 1 coulomb from infinity to that point against the electrostatic force is nothing but the electric potential. Now the total work done in moving a unit positive charge from infinity to point to that point is nothing but what? Now we are doing the work from infinity to this point, and this point is placed at a distance r from the origin. So now the work is done from infinity to this point, and the work done from infinity to this point against the electrostatic force is nothing but what? Electric potential. Is that right? Okay. So now electric potential V is equal to, now we apply the integration now. I hope you have studied already the integration part. When the work is done from infinity to that point, I write that is integral over infinity to r. Infinity to r, that is dw. Okay. So this electric potential is the work done in moving a charge of 1 coulomb from infinity to that point against the electrostatic force. So by applying the integration infinity to r dw, we will substitute the values of dw. What is? It is minus 1 divided by 4 pi epsilon naught q divided by x square into dx. X square into dx. Therefore, in this equation, charge and 4 pi epsilon naught are constant. The point charge and the constants are taken outside. So it is minus q divided by 4 pi epsilon naught integration over infinity to r. What remains inside? It is 1 divided by x square into dx. X square into dx. Or we write it is minus q divided by 4 pi epsilon naught integral over infinity to r. 1 by x square can be written in the form of x raised to minus 2. 1 by x square can be written in the form of x raised to minus 2. Now, there is one standard formula of the integration. What will that? Integration of x raised to n is equal to x raised to n plus 1 divided by n plus 1. This is the standard formula of integration of x raised to n dx is equal to x raised to n plus 1 divided by n plus 1. What we have here? It is integration of x raised to minus 2. Right? We have got x raised to minus 2 here. So x raised to minus 2 can be written. It is x raised to minus 2 plus 1 divided by minus 2 plus 1. Right? Or we will write that is x raised to minus 2 plus 1, it is minus 1. Minus 2 plus 1, it is minus 1. So integration of x raised to minus 2 can be write it is 1 minus of 1 by x. So this can be write as a integration of x raised to minus 2, which is equal to minus of 1 by x. Okay, so this form of integration can be write directly as x raised to minus 2 is equal to minus of 1 by x by using this formula x raised to n dx is equal to x raised to n plus 1 divided by n plus 1. Okay, so I will write directly here, that is v is equal to minus q divided by 4 pi epsilon naught integration of x raised to minus 2. What we get here, that is minus of 1 by x integral over infinity to r. Right? So this minus get plus, therefore I write q divided by 4 pi epsilon naught. Now substitute the values of numerator and denominator. First it is 1 by r. Substitute the values of r and infinity in x. So it is minus of 1 divided by infinity. Right? So anything divided by infinity is 0. Anything divided by infinity is 0. What remains here? 1 by r. Therefore electric potential V is equal to, we write 1 divided by 4 pi epsilon naught q divided by r. That is the expression for the electric potential due to the point charge. V is equal to 1 divided by 4 pi epsilon naught q divided by r. So now here electric potential due to the positive charge is always positive. Electric potential due to the positive charge is always positive. If there is a negative charge, electric potential due to the negative charge is negative. For positive charge, electric potential is always positive. For negative charge, electric potential is negative. And remember, electric potential is a scalar quantity. It is a scalar quantity. So this is for the today's class. Please try at home to solve this derivation. Is very important. Usually asked in the examination for the 5 marks. If you have any doubts, clarification, please make a comment on the channel and do not forget to subscribe this channel. Thank you.